Well, the next reaction that we're going to look at in chapter 17 is nitration. So again, the mechanism is going to look very similar to what we saw for the halogenation, with the exception that the electrophile will just be something different. So here the electrophile is NO2+. Well, let's look at the observed reaction. So we need to make sure we know this. So here you have benzene with nitric acid and sulfuric acid. So the sulfuric acid here behaves really as a catalyst. It allows this nitration reaction to proceed at lower T's and more at a faster pace. In the end, what we get is a nitrated product. We get an NO2 on here. So just like bromination, there's this preliminary step that we're going to have here. So let's take a look at the preliminary step. So we're going to take nitric acid. I don't know if you guys remember the Lewis structure of nitric acid, but you could probably tinker around with it pretty quickly and figure it out. So here we have nitric acid, and to this we will add sulfuric acid, and sulfuric acid looks like this. And we basically get like an acid-base reaction. So what's going to happen is this oxygen here is going to grab another hydrogen atom. So we're going to swing over here just like so and grab one of these H's from H2SO4. Okay. Now when we do that, we're going to form the following molecule. So it's a protonated form here of nitric acid, where we have essentially a water molecule hanging out down here at the end. Okay. So what happens next is that we come over here and do this, and then we kick off H2O. So last reaction over here, you have H2O plus this guy. And that is going to be your electrophile. So a little note here, this is your E plus here, it's your electrophile, and it is called the nitronium ion. All right, so for the sake of what we're going to be doing from here on out, we're essentially just going to take this when we talk about nitration. So we're not going to write out that preliminary step over and over again. All right, so let's take a look at the reaction down here. So here we have benzene, right? And we're going to add our nitronium ion. So let's put that in here. So nitronium, I'm going to write this thing up on its side so I can fit it in. There's your nitronium ion. Again, that's just your electrophile, so all you're doing there is that same general EAS reaction that we saw before, except there's going to be an additional little flow of electrons here. So what that's going to give us here is our double bond here, double bond here, and then I'm just going to put it up on the top carbon, so that's going to be an H atom that's there. And then the nitrogen here is going to be connected to an oxygen and another oxygen with a minus charge and a plus charge there. So I want to leave that out for you in this first structure. And after this, we'll just write NO2. And then down here below, you got your H with a plus charge. All right, so again, this is your sigma complex, so it's the same idea that we saw before, and same idea with moving our electrons around that ring. All right, so you got your double bonds here, here's your H, and then we'll write that as an NO2, and then we have a plus charge down here, and then we're swinging around like this so that we have our double bonds like that. Again, there's your H, there's your NO2. Right, now, one thing I want to point out to you is that that atom here has a positive charge. So you can see that when you write out the NO2, but like the Lewis structure of it, right? But when you just write out the letters NO2, it kind of masks that positive charge. Now the other thing, if you're being really particular, there are other resonance structures, because for each of these you could have resonance in the nitro group, but that's not really something important for this problem that we're looking at. All right, so then you have your next step, right? So remember we said sulfuric acid behaves as a catalyst here. So we're going to have this revisit us from sulfuric acid, and it's going to grab a hold of a proton. So we're going to swing around here and grab a hold of this H, and then come down and do that. So that gives us our double bonds, and then our NO2 here, right? And then also here, you get technically, right, you get an HO, right, in place of where the oxygen was. So you gained an H on that oxygen. So there's your sulfuric acid back. Right, now, other thing just to mention to you guys here too,